Before we jump into the actual meat of it, I'm going to talk a little bit about what different kinds of index machining, at least the way we see it in our system. We see that as three different types of index machining. One is a 3-axis indexing, and then the other one is 4-axis, which some people would call it 3+1. Basically, that's 3 axes, 3 simultaneous axes, and then 1 axis that can move and be locked. And then 5-axis indexing, or 3+2, very similar, where 3 simultaneous axes can move, which is basically would be 3 linear axes are moving, and then you have 2 rotary axes that can be rotated and locked. So these are we see it as 3 distinct classes of index machining, and all of these are, we have options in the system to enable you to do all 3 of these types of machining. Okay, before we get started, again, let me define what coordinate system, the different types of coordinate systems we have on our CAM system, as well as in the shop floor that you might encounter. The most important one, obviously, is the machine coordinate system that is shown on the graphic on the left side. So this is the coordinate, machine coordinate system is basically defined by your machine tool vendor. When they create the machine tool, they will let you know what the 0 is and what the x-axis, what the machine tool is thinking the x-axis is, and the y-axis, and the z-axis, of course. Typically, the 0 is when all the motors are zeroed out, where the head comes to rest, is where the 0 would be located. And that's where most machine tools would define their machine coordinate system 0. And then the x and y and z are really up to the machine tool vendor. Each of them define it differently, but what I've seen in the industry mostly is the x-axis. As you stand looking at the machine tool for 3-axis machines anyway, is the x-axis is going towards your right, and then the y-axis is going into the machine. So that's typically how it is defined. Okay, and then, what in the machine tool system, that's fine and dandy, but how do we translate it to our CAD system? Because we're not working in the machine tool environment. So we have, in the CAD system, we have something called the design coordinate system, or what we call the world coordinate system. So we have to match the machine coordinate system with the world coordinate system in the CAD environment. So the only requirement that we have to make things easier for you as a programmer is to make sure that the world coordinate system is aligned with the machine coordinate system. That's all is needed. You just need to align it. When I say align, you just need to make sure that the z-axis of your world coordinate system is parallel to the z-axis of your machine tool coordinate system. And then similarly, the x and y axes of your machine tool coordinate system are parallel to your, the design coordinate systems are parallel to your machine coordinate system. So once you do that, typically machine tool vendors have the ability to actually reset the 0 of the machine. And so long as you have the design coordinate system aligned and the machine tool coordinate system aligned, you can redefine your 0, and which is what we call the program coordinate system, which some people also call it the workpiece coordinate system as well, which is basically where the 0 and the x and y z axes of the workpiece is defined. And most machine tool vendors will give you the ability to actually reset the 0. And so as long as the axes are aligned, you can reset the 0 to coincide with your design coordinate system or your world coordinate system. So I'm using a lot of words here, but important things to remember are machine coordinate system and your workpiece coordinate system or your part coordinate system. In our system, in our CAM system, the part coordinate system is defined by a setup, what we call a setup. And we'll talk about that in a minute later. But that's how we define the machine coordinates, the program coordinate system. And then and to add to that confusion, confusion for some people, but it's actually a pretty nice feature. We can also have a work 0 offset. So you might have a program coordinate system sitting somewhere, but on top of that, you have the ability to actually move the 0 in XY to somewhere else, XYZ actually, in 3 linear axes, to some other point. This is actually a nice feature because let's say you programmed a part in a certain location, but now when you fixture the part on your table, it's actually on a different location and you don't want to change the 0. Then all you do is tell the machine that your 0 is actually offset by a certain distance, and that's where all the toolpath coordinates are going to be interpreted from. So that's a nice feature, and we'll talk about that as well. So I hope that makes some sense on all the different coordinate systems that we have in our system, in our CAM system, and some of this will become clearer as we talk, as we look at the demo a little bit more.